Hello, I'm Ole from Germany. So sorry for my bad English, but I want to present some modifications I did for my Qidi X-Max 3. And let's start with the simple things. You can see the door hinges are modified. Between these were plastic rods. I cut them away with a fine mechanical tool. Yes. Quite simple. And I drilled holes where the former plastic rods were. Of course, this is only a dent, not a hole, because I want to put a rod through it. And now I can take the door, put it in here, use a rod if I find it. Oh, that's a problem. I have maybe if I find it later. I can put it through here, and then the hinge works as normal. I can pull the rod again, and now I'm worried where it is. I had it in my hands a few minutes ago, but okay, you have enough fantasy to imagine a rod. Imagine a rod here. It works perfectly. I can pull it. I can put away the door, and if printing PLA, the door isn't in the way anymore. Actually, this was the first mod I did. At the second day I owned this printer. So, quite interesting. Also, second modification, or it's not a modification, but just a hint. These 310 by 310 spring steels cost a lot less than the original sheet. And in most cases, they are big enough. I consider spring steels a consumable anyway. Here you can see I damaged the original one. I actually on live Z adjust wanted to correct 0.01 millimeter, but I selected 1 millimeter. So the nozzle crashed into it. The plastic was very into the bed, and trying to remove it, the bed is damaged. Still the other side works, but I think before I destroy this, I use a cheap one from AliExpress. It was 16 euros. Even has this nice other side here. While these should cost 50 euros. So just about 50. And most pins fit onto this plate. So I have ordered some of these. As said, I consider it a consumable, and I only use this if I need the size. Most cases this works well and can save a lot of money. Of course, I added a webcam here, and these are the simple mods I did. Now to the more complicated ones. If you unload a filament with the original hot end, it's still too weak while passing the gears. So if you don't pull the filament on the end, it might get tangled inside. Actually, this happened the first time I unloaded filament from this printer. The menu says you have to pull the filament. So I'm not so happy because I thought I could add a filament changer, the enraged rabbit carrot feeder, but it wouldn't work with the original hot end. So I modified the hot end. You see, it's a Revo now. It's very provisorically, but it works. It works very well. What did I use? I made a simple adapter plate with holes. I use a boron cold end. I bought a extra extruder. The second one, because I always wanted to be able to go back to original. So this is the extruder. I use the rotary tool to cut this off. Then I flattened it out. And then I used the adapter plate, put a short piece of bowden in the middle and a 2mm rod to place it correctly where the filament comes, and then drilled 2 holes with 2.5mm diameter to screw it onto the feeder. As said, it's a provisorium, but it works. However, on this side there is the lever inside, so you have about half or 3/4 of a millimeter you can screw into without blocking the lever. So I need some washers, so the screw holes. When I unscrewed it again, screwed on the Revo boron cold end, put a tube inside. You need a very short piece of tube, cut it flat, chamfered it, screwed it back on, heater, nozzle, and mounted it. To cool it, I use this V6 cooler. I had some flying around, and also used a rotary tool to cut away what's not needed to fit it. And this is the result. Here I glued this to the print head. Not an elegant solution, but I hope someone will make a cover soon, and then I can integrate it in the cover. This fan is a bit bigger than the original, so I also had to drill away some of the plastics, and I even scrapped into the fan, but it doesn't matter because the blades end here, so the blades are not damaged. The fan still works fine. I have to use some tape to fix it because after all these experiments the hinges here are broken. But it works. It works well. With the Revo high flow nozzle, same problem on unload. You have to pull it. But if you use a Revo standard nozzle, you get a perfect filament tip. Which means if I want to print multicolor with an enraged rabbit carrot feeder, I simply screw in a standard nozzle, if I print normally in one color, I can use the high flow nozzle and I can use the obsidian nozzle if I want to print abrasives. Of course, I have to recalibrate linear advance, pressure advance, because the melt zone is smaller than on the original hot end, even with a Revo high flow, because high flow is achieved here by the CHT technology, splitting the filament to increase surface area, not by a bigger melt zone. And the size of a melt zone affects the delay between extruder movement and filament output, as molten plastic has some viscosity. So you can't use the standard slicer settings here. The print head itself had a thermocouple, not a thermistor, the original one. You can actually recognize that these metal shielded cables are practically always thermocouples, not thermistors. So I couldn't connect the thermistor of the Revo to the PCB on the printhead. So I put an extra extension cable to the cable chain. No problem. But where to connect? The board is an adapted version of a skipper, and it has no connectors for the hot end at all, as this printer has its own toolboard on the hot end. But it uses Klipper. So I could add another board, and some might recognize it. It's a Creality main board. It's the silent board. Why the silent board? I could also use the non-silent board, but the silent board has a bootloader and can be flashed with a sonic pad. I'm a beginner in Klipper, and so I don't want it to go into everything, and I simply use the sonic pad to flash Klipper. I configured it as a third MCU, and I've changed the sensor input for the hot end to the hot end thermistor input on the Creality board. And it works well. Actually, I'm very happy with the solution. Besides having a nice filament tip on unload, so I could add a filament changer with standard nozzle or obsidian. All these nozzles from EFD have the same length, very, very precisely the same length. So I can change the nozzle without readjusting the offset, which is an advantage of the solution. Of course, it isn't cheap. The Revo is a quite costly product. In my opinion, it's worth it. And also, I already changed some of my Prusa printers to E3D Revo systems. So I have nearly all nozzle sizes. I have obsidian 0.4, 0.6. So all I needed here was Voron hot end, and this set with cold end, 2 nozzles and heater core actually costs about 85 euros on last sale on AliExpress, which is quite cheap, I think. And if I need an obsidian, I obviously already have one anyway, so it's no extra cost to me. If it's your first printer you want to add a Revo, with all these nozzle sizes, etc., you can calculate 500-600 euros to get a complete set. Here, of course, it's only less than 100 euros. Oh no, actually 120 euros, because I bought one 0.4 high flow Revo nozzle. You don't need the other heater core. Still, this uses a 40 watt heater core. I don't recommend using the 60 watt heater core for high flow with higher diameters, because the board actually is connected via USB, and there is a limit of current you might send through the cable. So I'm not sure the board would support higher wattage. So yes, this is improvised, but it works very well. And as said, I hope someone designs a new cover so I can make some adaptations. I'm not very skilled in designing, so I cannot do it myself. Another upgrade I made was this. This is the MKS adapter for the eMMC. So you can make an image, so you have a backup, and you can also write it back. However, it's only 8 GB. This is for the Orange Pi Nano or also M4. Search for M4 and Pi and eMMC on AliExpress and you find this model. It hasn't the screw holes up, but it has exactly the same connector. So I imaged the firmware onto the PC and I wrote it to this flash. Then I used SHA and sent the command to expand the file system, and now I have a lot of memory. Many people use an USB stick for the G-codes. As I use one USB port for the webcam, one USB port for the third MCU, and if I want to add wireless LAN, I need the third output, and all are used. So normally I would have the wireless LAN stick on the top, because actually if it's placed correctly, the printer, having the wireless LAN on the back would be the opposite to my router, so not a good receive signal. Yes, this was, oh, and also I changed, of course, the Bowden tube to a longer one. Make sure you use an inside diameter of 3 mm, because the friction actually can lead to under extrusion. I had these problems with an 2.5 mm inside diameter, so definitely use 3 millimeter inside. I also removed the filament runout sensor, unscrewed it so I can reach it from the side. I also will make an extension cable, haven't done it yet. So these were the changes are already made. Where some other I plan to do, as I use a third MCU, I also have 2 heater outputs, and these are optimal to dim LED light stripes. There is an LED light stripe inside, but I plan to replace it by this corp because they give a much more even light, and also I want a light stripe in the back. So if I view from the front, having the front light stripe on is totally okay, but if I use the camera, this camera points to the light stripe, which is not good for picture quality as it blends. So I want another light stripe in the back, and I want to change which light stripe is used. Maybe the other still at 10% or so to make the shadows less harsh. So it's something I want to experiment with. And as I have a third MCU, this is totally okay. So these are the changes I made and plan in the near future. However, the main board Qidi uses is actually a reduced variant of this MKS skipper. And it should be possible to change the board, so I don't need a third MCU anymore, because this obviously has thermistor inputs, not thermocouple inputs, and also maybe change the tool head board. These also have thermistor inputs, not thermocouples, and they have a lot of other inputs and outputs. So you can add NeoPixel to the printhead, you can add a filament runout sensor, or let's call it filament sensor. If you have an automatic filament changer, you can sense the filament by lever movement, maybe. So it can detect if a filament actually is grabbed by the gears. So nice features I might add later. And as the original parts also made by MKS, there shouldn't be compatibility issues. So another thing, the firmware at the moment uses Armbian Jessie, quite old Linux version. There is a Bullseye version for the MKS Pi and MKS Skipper on GitHub. So if you want, you can use the newest Linux and also the newest Klipper modules, because, for example, the webcam software installed on the Qidi is an older version. You can't get the newest version as it doesn't work with Jessie. So that's what I did and what I plan to do. I hope this video was helpful, and have a nice day.